All right, this is a video on molality, and molality is something that we'll study in our solutions unit. And what it is, just another way of measuring the concentration of a solution. And we already know one way to measure the concentration, which is molarity. So you might be asking yourself why we need both molality and molarity, and I think that's a fair question. Let's look at both of those equations. The equation for molarity is this one here, moles of solute over liters of solution, and that liters of solution includes the solute itself and all of the volume needed to make the overall solution. Molality is a pretty similar equation, moles of solute over kilograms of water, and the difference here is obviously the bottom part of this fraction. And the kilograms of water, that's just the mass of the water that's used to make the solution. And this doesn't have to be water, but because we're talking about aqueous solutions, then it will always be water, okay? And so what's the point of having both of these things? So molality is based on mass, and that means that the mass of water is not going to change as the temperature of the solution changes. And we know that temperature can change volume. We talked about this with gas laws. We know that like a gas that we allow to heat up, assuming it's not in a container, will expand, and water and liquids and solutions will do that too. And molarity will change because it's based on volume. And so that's a problem when we work with solutions that are changing temperature, because if we start with molarity values of concentration, then as the temperature gets hotter or colder, the volume of that solution can increase or decrease, and that can lead to inconsistencies of the concentration. And so we want to use molality when we do certain types of work involving the temperature change of certain solutions. Okay, so here's some equations that are just the derived equations for molality. And I think this is helpful as you move forward in some of your practice work as you're solving for each of the three variables. Molality is moles over kilograms of water. Moles of solute you can calculate by multiplying the molality by the mass of water. And then the mass of water can be calculated by dividing the moles of solute over the molality of the solution. And this is a good time to talk about some things that are important about water. And so with water, as long as we're talking about water, 1 milliliter is equivalent to 1 gram. And so lots of problems have water measured out in milliliters, which then we can equate to grams and then convert quickly to kilograms. And so 1 milliliter is 1 gram. That means 1,000 milliliters is the same as a liter, which is the same as a kilogram, and 1 liter is equivalent to a kilogram of water. And if you're ever given milliliters or grams of water in a problem, you got to divide that by 1,000 to get into kilograms. Okay, so let's do a couple of practice problems here. This first one's nice and easy. What is the molality of a solution made from 1.6 moles of sodium chloride in 950 milliliters of water? So again, this sodium chloride could actually be anything in this problem. It doesn't matter what this is because we're not dealing with grams. So that could be anything. The only change we need to make here right away is to divide the 950 by 1,000, and this is 0.950 kilograms of water. And that's the number we'll use in our problem. So we just use our simple equation, molality equals the moles of solute, 1.6, divided by the kilograms of water, 0.950. And let's see, do I have a calculator? Yeah, I do. A good one, too. 1.6 divided by 0.95. Oh gosh. 1.6 divided by 0.950 equals. So this is a 1.68 molal solution. Okay, so some are easy like that, and some are a little bit more challenging. Like Like here's a little bit more challenging one. How many grams of calcium chloride are in a solution that is 1.6 molal and it's made with 2,500 milliliters of water? Okay, so first thing that I can see to do is to divide this by 1,000. This is 2.5 kilograms of water. So that's a number we'll use here. And then, so when it's asking for grams, you got to remember the pretty close relationship between grams and moles. So when a question asks how many grams, it's really asking how many moles, and then you can make a quick conversion to grams. So this is the equation we're going to use for this question. Excuse me, moles of solute. So we're going to multiply the molality by the kilograms of water. Okay, so molality, moles equals the molality of 1.6 multiplied by the 2.50 kilograms of water. And let's calculate that. Times 2.5 equals 4. Did I do that right? Let me do that again. 1.6 times 2.5. Yeah, 4. Okay. I wasn't expecting such an easy number here. So there are 4 moles of calcium chloride, which is CaCl2. Okay. The question though is how many grams. So we need to convert this number of moles into grams, and we know how to do that. 4 moles. 1 mole down here, and the molar mass of the compound is going to go here. So calcium is 40.08 plus 2 chlorines plus 35.45 plus 35.45 equals 114.98. Okay. That's the molar mass of calcium chloride. Then we're just going to multiply the molar mass times the number of moles, and that gives us 459.9 grams of CaCl2, and that's our final answer. So as long as you have 2 of the variables, then you can solve for the third. Sometimes you have to do a little converting between milliliters and liters, or milliliters and kilograms, or grams to kilograms, and then you might have to do some calculations between moles and grams, but these aren't too challenging. Okay, hope that helps.